Okay, so for our second video here, I was just going to real quick demonstrate the timing diagram process uh, and do that for the same example that I just showed in the bus version. So if you're on Windows, you'll be able to use the timing editor. It's probably simple enough you can get it running in Wine and in Ubuntu or Mac, but you might have to draw it, sketch it out using an image editor. uh, my favorite image editor is GIMP. So if you just search for GIMP image editor, um, which is pretty standard photo editor. I use this one. It's the new image manipulation program. It'll let you draw straight lines very easily, um, which is pretty nice. I think you just have to hold control, and it'll just let you really quickly sketch it out. So it's pretty nice. But if you're going to use the timing editor, let's see, it's here. So I'm going to pop open the timing editor, and once it opens, so I'm going to start a new file, and so we've got a clock signal right here. Um, I'm going to change the length of a period to make it a little bit wider. Um, and then that way I have lots of room to work. I'm also going to, so that I mess with that by clicking on the dot. You can click on this to give yourself a little bit more space. As we saw in our example, we need to get to clock cycle 3. So I'm just going to run this long enough. It'll can just so that it marks clock cycle 3. You'll probably be good making it to about here, but okay. So we've got our clock. There's a lot of space. It starts at 0, which is good. So now I'm just going to sketch out the timing editor at the same time as I manipulate the full function ALU here. Oh, this is the partial build version. Where's the one I want? This one? No. This one. Okay. So I'm going to reset the simulation real quick. Okay, so everything is just like it was. So the next thing we actually need to do, though, before we get to this, I have two timing diagrams open. So before we can do that, in this program, we're going to have to set up the timing traces that I set up in the document. So let me grab the document. So I've got the list. I've dropped A, which is the bit 0 of the address. So the next thing I'm going to do is start adding traces. So we're going to go A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V. All right, so we've got them. So now it's just a matter of naming them all. So give me a moment. I'm going to name them all, which you can do by not clicking on the name, but then draw, edit text labels. Okay, so now I can edit the text labels. Okay, so you might have to pause the video for a second to compare this list with that list. I forgot that U is clock, so I moved the clock. I left the clock on the top. It's a little bit neater there. And then I need to fix this label. It's slightly off, but um, okay. So I erased that last trace, and everything should be good now. So you can kind of follow along with this list. So now we'll take this one clock cycle at a time. And now, okay, so we're going to line these up against each other, and I'm going to zoom out just a little bit more, just so that it's a little bit easier to see everything side to side. So the first thing that we have to do is line everything up. And so what we're going to do is, until we trigger the clock is low. So while the clock is low, we're going to line up all of these lines here. So last time I had, I believe, 7, 5, 6, and C. preloaded, and so now it's just a matter of lining up all of our lines. All right, so the first move we have to make is we're about to kick our value onto B. B is the value in ROM 2. So we'll just start lining things up and marking the relevant lines. So I'm going to point to location 2. Off to the left, the traces I want you to trace are the outputs to the decoder. So at the moment, all of these are low except for address 2, which we're kicking high here. And so all the rest of these are low. We also are going to want to read from location 2. So let's kick read up. By doing that, the value on ROM 2 is on the bus, so depending on the value of the ROM 2 you had, it would cause a different value here on data bus. But since the value is 5, that's this line and this line, the 4's place and the 1's place. So we've dealt with these, we've dealt with these, right? We're intentionally keeping low. We're not outputting the accumulator. Where we did an input to the accumulator, we wanted to make sure that the clear line was high so that it didn't, so that it was not actively clearing. The opcode value doesn't matter, so I'm just going to leave it at 0. That's fine. And then the ALU input A/B prime, it needs to be routed upward in the B direction, and that's what we want. So all of this should be accurate. Okay, and so we're actually going to propagate these. We're about to trigger the clock. So none of these things are going to change. The contents of the register are going to change, but that's not one of the things that we're tracing. So we're about to propagate this through the clock cycle. Okay, so I'm going to trigger it. What happened? Oh, the input to the ALU register. I need to set that up. Okay, so the input to ALU register. All right. Okay, I forgot, which might happen to you, but okay, so we fixed that. So now we trigger the clock. That causes the move, and we're good. Okay, so once we've passed the rising edge, and then we bring this back low again before we mess with anything. And so in my case, I'm going to be as accurate as possible and actually continue these all the way through the clock dropping. Technically, you're fine once you pass the rising edge. It just has to be retained through there. Whether you change it while the clock sits high or sits low doesn't matter, as long as we're about to reach the point that we are going to raise the clock edge again. So the next piece we need to do is load ROM 3 into, or read from ROM 3. So the read line is going to continue through the clock cycle. So I'm just going to extend it all the way through. We're not activating the write. The clock we'll deal with later. We're going to need to swap the direction on the ALU input A/B prime. So we will kick that up starting here through the rising edge where things happen. I'm watching something on Twitch while I'm doing this, peeking down as I talk about this. So let's see. Right, so I updated this, so we need to swap that around. We no longer want to change the value in the ALU register, so that's going to go low. We need to still make sure that we're not wiping the register, so that's going to stay high through here. The accumulator is almost ready to activate, so I'm going to bring that up. Right now, 5 is being routed down here. We still haven't switched it to point to location 3. Upon doing that, that changed a couple things. One, the decoder address value has switched from 2 to 3. So that's low, that's high now. We've, I think, accounted for all of these lines except for the opcode. So we'll fix that in a second, but the other consequence of this is that the data bus now contains the value from over here. It is a 7. Depending on what value was here, you'd get a different data bus value. But in our case, it's 7, so I'm going to bring those values through. That turns on our 2's place. And so then the last thing is to make sure our opcode is set up. So the subtract code is F, which is 1111. So again, opcode 3 is at the bottom here. So that's the first one, the second one, the third one, and the fourth one. And so I believe all of these are accurately placed. Except I turned on the input to the accumulator and I forgot to draw it in. Oh, okay, I drew it on the wrong one. So sorry, so this is... Okay, and I never remember which one's going to cut it. Okay, there it goes. This is for the writing stage. Okay, so we're input to the accumulator. Okay, I fixed that quickly enough. I was hoping to not make a mistake in this video at all. Oops, that's still better than the one I had before. I fixed it a lot quicker. So now everything's ready for a clock edge. It looks like I didn't extend this as far as the others, which isn't really a big deal. And so now we're ready to trigger the clock. Okay. So the clock rises and then it falls. So for accuracy, I'm going to propagate all the lines through the falling edge. And then we're going to set everything up before we raise it again. And so we're just approximating the timing diagram, right? I'm not being super precise about exactly when I toggle them, but it does show in relation to the clock when they're true and when they're false. Okay, so we reach the edge of okay. This program's not perfect. Okay, so now everything's low. We just need to set up for our final. Okay, so we propagated everything through to the fall, and so now we just need to load the final result into RAM 6. So we're going to turn off the read, turn on the write. Okay, so read is off. Write's going to be on at least through the rising edge. Once the rising edge occurs, it doesn't matter what else we write. It's properly loaded. So I'm just going to take it to here because I can't reach all the way over. If you wanted to run it all the way to the end, that would also work, but I'm kind of running out of space here. I mean, I guess I could sneak up here and just cut the edge a little closer. Oh, okay. Then I had it. All right. Perfect. So we're going to run the write over. We're not going to read the... Now we're going to kick the 2 onto the bus. So we've stopped reading, we're writing. We're going to kick the 2 onto the bus. So that's the output accumulator line. That finally goes true. We're not replacing what's in the accumulator, so we're going to bring that low. It's already there. We're not going to clear. So run the clear all the way through input to ALU register. It doesn't matter which direction it's pointing. So it's technically high right now, so I'm going to draw it through, although it doesn't matter whether it is or not. Just to be accurate, we'll do that. The opcode no longer matters, but I'll continue to keep the opcode as I left it, even though it doesn't matter what value it has. Let's see here. What else are we messing around with? So that's fine, that's fine. We're not changing the input to the ALU register, so that's fine. Okay, so we've dealt with the entire bottom zone here. So now, of course, by pushing the 2 onto the bus, 2 is what is now on the bus. So the only value that is high now is the 2's place. and we're trying to write to memory location to RAM 6. So I need to change the address to 6, which changes the contents of these. So now it's 6 that's high. And then I counted for all the lines. So then clock goes up. And whether or not I bring it back down, the result is stored in RAM 6 and we're done. So that's how to set up the timing diagram. So that kind of guides you through everything. It basically gives away the answer, but that's okay. There's one that's on the thing that's slightly more complicated. So this one's basically a freebie. There's a version of this, and then there's one with more steps. But yeah, have a good day, everybody, and I will see you next time.